Here we have another example. I have a DC motor connected to a load, a dynamometer system, but through a series of gears. The number of teeth on these gears are given here, and 1, 2, 3, 4. The mass moment of inertia of the armature and the damping are given, and of the load are here. Instead of the plot of torque versus speed is given to me as an equation. The motor torque is an equation of a straight line, and what's required is to find this transfer function, the output theta L, the rotational speed at the load, versus the input voltage E A. The test voltage E A is 100 volts. Now, transfer function at the motor G S theta motor divided by E A is KT divided by R A J M, all divided by S plus 1 over J M C M plus KT KB divided by R A. And that's theta M to EA, and we'll get to the point where we find theta L. So let me find these parameters. I'm going to need again the same things. I need JM, CM, KT divided by RA, and I'm going to need KB. So now let me start with JM, the mass moment of inertia at the motor axis. I have the mass moment of inertia of the armature plus the mass moment of inertia of this load, JL. Now, we're going to need to transfer this mass moment of inertia from this axis to the motor axis. So first, I'm going to do this in steps. First, I'm going to go from N4 to N3, from 4 to 3. So that would be JL, the target is N3, the source is N4 squared. And then I'm going to go from N2 to N1. From 4 to 3 brings me to this axis. From 2 to 1 takes me to the motor axis. So I'm going to multiply by the target is N1, and I'm starting from N2 squared. And that's going to be my equivalent mass moment of inertia at the motor axis, which is going to be 1 plus J load is 400, N3 is 25 divided by N4 is 100, all squared. N1 is 20 divided by N2 is 100, all squared. And that will add up to 2 kilogram meter squared. And then again, I'm going to do the same for the damping at the motor axis. It's going to be CA, damping of the armature, plus C load. And again, the same transformation from N4 to N3, and then from N2 to N1. So from from 4 to 3 and from 2 to 1. Damping at the motor is 5 plus at the load it's 800, 25, 100 squared, 20, 100 squared. This is 1, then this is 2, and 5, that's 7 Newton meter per second. And that's my damping at the motor axis. Next, we're going to need to find the KT over RA and the KB. And let me come to this equation. Tm, let's talk about the stall torque at stall. At stall means that the omega of the motor is 0. That's where the stall happens, which means that T stall substitutes omega equals 0 in here, you will get 200 Newton meters, and that's at stall. At no load, which basically means that the torque is 0, then omega no load is substitute 0 in here. Omega becomes 200 divided by 8, that's 25 radians per second. So now I have my stall torque and the no load omega. So now KT divided by RA is stall torque divided by test voltage, and KB is the test voltage divided by omega no load. So KT divided by RA is going to be 200 divided by the test voltage that's given here, 100, that's 2, and KB is the test voltage 100 divided by omega no load is 25, and that's 4. Now I can substitute back into this transfer function G KT divided by RA is 2 divided by JM, which is 2, all divided by S times S plus 1 over JM is again 2 times CM 7 plus KT over RA is 2 times KB, which is 4. So that's 1 divided by S times S plus 7 and 8, 15 and a half, 7.5. This is the transfer function of theta M to EA. But what's required here is theta L. It's very easy. I know that there's a relation between theta L and theta M. Okay? theta m is equal to, let me go from theta L to, let me call this theta, what, theta 2. From theta L to theta 2, I'm going to go through this gear ratio. Okay. So it's going to be 100 divided by 25, and then from N2 to N1 is going to be 100 divided by 20 theta L, which means that theta M equals 10,000 divided by 500, that is 20 theta L. Okay, so if this is theta M divided by EA, so that's also 20 theta L divided by EA, because theta M is 20 theta L. If I'm looking for theta L divided by EA, simply I'm going to divide by 20 here, so I'm going to end up with 1 divided by 20 over S plus 7.5, and that's my final answer. And that's the transfer function between the output or the input EA and the output theta at the load side.